All right, page 82 in your textbooks. Let's go and take a look at your homework review, numbers 1 through 6. We'll also go back to page 76 and look at review numbers 7 through 12. On numbers 1 through 6, you are identifying the equation as either a conditional equation, which means x has to equal something, some actual number, or perhaps, we looked at yesterday, a couple of numbers possibly. We said an equation could be an identity when x is true for all real numbers, right? Anything. And then we also have contradiction for which x is equal to nothing. No solutions whatsoever. Number 1, what did you get for your answer, Maddie? B equals 5, and it is a conditional equation. Number 2, what did you get, Michael?
A equals 8.
Not 8.
A equals 7.
A equals 7. Should have subtracted the 36 from both sides, or moved the 36 over as a negative 36 to get negative 6a equals negative 42, and then divide both sides by that negative 6 to get positive 7. It is a conditional equation. Back to Michael for redemption, number 3.
X equals 4.
X equals 4, again a conditional equation. Number 4, Genesis. N equals 6, and again a conditional equation. Number 5, Abby.
X equals all real numbers.
X equals all real numbers because it is an identity. And how did you spot that it has to be all real numbers?
Everything canceled.
Everything canceled, leaving us with 0 equals 0, which is always true. Number 6, what did you get, Brandon?
All real numbers.
All real numbers, again, another identity, because again, everything canceled. How many went 6 for 6 on those problems? 5 for 6, just missed 1. All right, we understand the one we missed. Turn back to page 76. And let's take a look at the review 7 through 12. And these are what we began looking at yesterday, absolute value equations. And again, different from any of the other equations we've worked so far this year, in that an absolute value equation will often have how many answers, class? 2, because we're going to turn what was one equation into 2 equations. But what's the first key step, Audrey? She doesn't know. We should all leave her in here by herself and just abandon her. Does that help?
Let's go.
Abandon? Isolate the absolute value equations. So isolate the. I thought you just said it. Class. Absolute value. Isolate the absolute value. Get it all by itself. Then once it's isolated, you're going to make 2 equations. She needs some redemption, so we'll go back to Audrey. Maybe she remembers now. We're going to make 2 equations by doing what? Good, we're going to take whatever's inside the absolute value, set it equal to positive whatever was on the other side, and set it again equal to negative whatever's on the other side. So for instance, on number 7, Audrey, the x plus 7's absolute value is already isolated. We're ready to go straight to our 2 equations.
X plus 7 equals 11, and x plus 7 equals negative 11.
There we go, x plus 7 is equal to 11, and the x plus 7 equals negative 11 to get what 2 answers for x?
4 and negative 18.
4 and negative 18 are correct. Number 8, the absolute value is not isolated yet. What do we need to do to isolate the absolute value, Kendall?
You can multiply both sides by 2.
Good, if you multiply both sides by 2 or 2 over 1, it'll knock out the fraction on the one side, which leaves us with an isolated absolute value of w negative 2. Of course, on the other side, Kendall, we'll get
8.
So now we can make our 2 equations.
W minus 2 equals 8, and w minus 2 equals negative 8.
And you got what 2 answers when you solved?
10 and negative 10.
Oh, Michael?
10 and negative 6.
10 and negative 6. So here when I add the 2, I get the 10. Here when I add the 2, I get a negative 6. So be careful with the signs there. Number 9, absolute value is already isolated. Let's go back to Kendall for redemption. What do we need to do?
You set up 2 equations.
Are you looking at number 9 in your textbook?
Oh, yeah. Okay, it's no solution.
Right, and there is that time, and again, this is what makes the absolute value equations a little more challenging. There's a couple little things to think through. This is normally what we do, but if it's equal to a negative, we don't set up 2 equations, class. We just write no solution because we know that absolute value never produces a negative. Now, again, the key is you got to make sure you isolate first. We actually looked at one of those today in Algebra 1. We're reviewing for the exam. And we had our equations chapter a little sooner because we didn't get into all the radicals and fractions and stuff we did in this class. but they've already had absolute value equations. And in the review today, some of the kids saw the negative and went straight to no solution, but the negative ended up knocking itself back out again as you kept working the problem. So do make sure you isolate first before you make that call. But if it's isolated equal to a negative, no solution should be the answer on 9. Number 10, Maddie. Again, we first have to divide away the 7, but obviously that's going to leave you with a negative 1/7, which is still negative, which is still no solution. And then a number 11, here's where we may not get two answers because we have a variable inside the absolute value. We'll also have a variable outside. And when that happens, it's possible that one of our two answers may be considered, Michael, an
Extraneous.
root. An extraneous root or an extraneous solution, extraneous answer. You got the main word I was looking for. Extraneous meaning it's extra, it's not one that works, but it's also not that we mess something up, right? It's not, for instance, on a quiz or something, the correct answer is 7 and Abby's like, 14/9. She's like, well, that was an extraneous answer. No, you screwed up. No, an extraneous answer, she didn't screw up, it just doesn't happen to check. So on number 11, and here we have a binomial, which I think we only saw one example of this in class yesterday. We've already got the absolute value isolated. We need to set it equal to both positive and negative, whatever. Let's come to Abby. What are my two equations?
The absolute value of d plus 4 equals 2d minus 1. And the absolute value of d plus 4 equals negative 2 positive 1, or 2d.
There we go, good. Since the d plus 4 is what's in the absolute value, we're going to set that equal to both positive this, which means don't change anything, and negative this, which means change all the signs there. And now we got to solve two different equations. So let's start here, and we'll get to that equation in just a moment. Abby, finish this equation for us.
You subtract the d, and then move over the negative 1 as positive 1, and then 5 equals d.
All right, so there's our first possible solution. I don't know if it's extraneous or not, but there's our first possible solution. Let's go back to Michael for the other one. What here?
You gotta isolate the d, and you gotta move the negative 2d over, and then you gotta move the positive 4 over. And that leaves you with 3d equals negative 3.
Which gives us
negative 1.
Hey, no fractions this time. I'm a big fan of no fractions. Now we have our calculator, right? We worked yesterday on using the calculator if we needed it, but I'd rather not mess with them. Let's try the 5 first. 5 plus 4, class. 9. Absolute value of 9. 9. 2 times 5?
10.
Minus 1?
9.
Does it check?
Yes.
Yep. That means there's a very good chance the other one's extraneous, but not always, so we do have to take the time to check. Negative 1 plus 4.
3.
Absolute value of 3. 2 times negative 1. Negative 2 minus 1. Negative 3. Does it check? Nope. Sure enough, it is an extraneous root. How many got 5 to check? Negative 1 to not check. How many, maybe when you came over here to change the signs, you forgot to change all the signs perhaps? That's a common mistake. Questions, comments, feedback? All right, let's take a look at number 12. And again, we've got the absolute value equation. One variable in, one variable out. Brandon, since they've already written it with the absolute value isolated, I'm going to go straight to my two equations. What are my two equations?
4b minus 2 equals b plus 4. And 4b minus 2 equals negative v minus 1.
There we go, where we keep everything intact, change all the signs. So Brandon, as we solve the first equation, talk me through it.
Subtract the v, and then you bring the negative 2 to positive 2, and then 3b equals 6, divided by 3, and then equals b equals 2.
All right, so there's one possible answer. I guess I need to write the equation anyway in just a minute so we can check it. And then about the other one, Audrey?
Bring the negative b as positive. Equals 5b minus 2 equals negative 4. Move the negative 2 over as positive. Negative 2. And then get negative 2 fifths.
All right, so there's my two possible answers there. Got to plug them back in. 4v minus 2 Absolute value equals v plus 4. I'm definitely going to go with the easier one first, and that's the 2. Let's plug in the 2 class. 4 times 2?
8.
Minus 2?
6.
Absolute value 6.
6.
And 2 plus 4?
6.
6. This one checks. We're expecting that one. Number 1, it's negative. Number 2, it's just ugly. Probably extraneous, but let's check just to make sure. Calculator's at the ready. 4 times negative 2/5 on the calculator. 4 times negative 2/5 gives us what? Negative 8/5, or many of your calculators will say negative 1 3/5, right? Minus 2.
3 and 3/5.
Negative 3 3/5. But when you take the absolute value of negative 3 3/5, we're going to end up with 3 3/5. All right? Negative 2/5 plus 4.
3 and 3/5.
Oh, I think this is the first one we've seen where they do still both check. So I've said it all this time, don't assume the other one's extraneous, though often it is. And here, even though it's negative, even though it's weird looking, it does check. Both answers checking here for us. How many found that both answers would check? How many didn't want to plug in the negative 2/5 in the calculator and call it extraneous? All right, nobody like that? Questions on this? All right, move back to page 66 now. Back to page 66. I want you to do numbers 20 through 28, the even. Page 66, numbers 20 through 28, the evens. Some more practice with these absolute value equations. Genesis finished. Just a little bit longer to be finishing up. And we'll take a look at these together. All right, pencils down even if you're not finished. And let's go ahead and take a look at these together. The first one, again, could not be more straightforward. They already had this isolated for you, okay? Now, I write your quizzes and tests. I'm not going to insult your intelligence like that. Okay, so maybe there'd be a number here that have to get divided away, or maybe a number here that have to be added or subtracted to move it over, whatever. But they've got it by itself. So I'm ready to make my two equations, Maddie. In both cases, we're going to move it over as a negative 11 to get what? Two answers for y. 10 and negative 32 is correct. Look at the next one. Again, we're ready to make our two equations. It's already isolated. Brandon?
3b minus 1 equals 26, and 3b minus 1 equals negative 25.
So again, in both cases, let's start by moving the negative 1 over as a positive 1 to get
3b equals 27, and 3b equals negative 25.
which gives us what two answers for v?
9 and negative 25 and 3.
There we go, negative 25 thirds. If you happen to plug it into the calculator, negative 8 1/3, but I just leave it as negative 25 over 3. Look at the next one. It's not isolated. Genesis, what do we have to do to get the absolute value isolated? Divided with 8. What we do to one side, of course, do to the other. So when we do get it isolated, we'll get the absolute value of 2u negative 12 is equal to negative 4. Now what? No solution. There we go. Be careful, right? It's an easy trap to fall into. You just get in the habit of the two equations over and over and over again. Gotta watch for those negatives. How many good on the first three? Good on the first three. Questions on those first three? On the next one, I have to isolate the absolute value by doing what here? Kendall? Good, and this is a thing, and this is a thing. When we say multiply everything, every term by the LCD, which is 2, there's only two terms. One term on one side, one term on the other. When we multiply by the 2, what do we get?
The absolute value of 7 minus 5 equals 2.
There we go. You may say, well, what happened to the 1? Well, we just left it understood. We don't need to write it anymore. And so now we've got it isolated. Now we're ready to make our two equations, Kendall.
7w minus 5 equals 2w. And
of course, we need to solve, walk us through here.
You add 5. No, yeah.
Yeah, okay, all right, I'll give that to you. So we'll move the negative 5s over to get positive 5s over here. And at the same time,
Move the 2 as a negative.
right, normally I'd move to get rid of the W first, and that would tell me to move the 5 over there. But yeah, we move the 2W over as a negative to get.
5.
Here I move it over as a,
Positive.
to get
9.
9W. So what do I get for my 2 possible answers for W?
1 and 9/5. Or 5/9.
There we go, 5/9. And those are my possible answers. And I say that because there's a variable outside, which tells me there's a chance it may not work. So which one do we want to test first?
1.
Please, thank you. Let's go with the 1. Let's come back to the original here. 7 times 1, of course.
7.
Minus 5.
2.
Absolute value 2.
2.
Half of 2.
1.
1. And then of course if W is 1, 1 equals 1. Okay. So this is an answer. Let's see if the other one is as well. Calculator at the ready. If you didn't already do this, calculator's at the ready. 7 times 5/9. Kendall's going to give us the answer, but all of you entering that in if you haven't already.
3 and 8/9.
Okay, minus 5.
Negative 1 and 4/9.
All right. And then take the negative sign off. That'll take care of absolute value. And then times a half.
5/9.
5/9. And then, of course, if I plug the 5/9 in here, that's just...
2 and 5.
No, 2. We multiplied it 2, but the original had a W, right? So it's just 5/9. So my answers are 1 and 5/9. They both check. How many found that they both would check here? No extraneous root. Only Brandon. Genesis as well. Okay. Questions? We see it now. How many got those 2 and just maybe didn't finish the checking process? Okay. Questions?
I got 9 over 5. I did it wrong.
Okay, so you did what she started to do. She actually said 9/5 and then caught herself. Okay, 5/9. And of course, the 9/5 would not check, right? Questions on this? Let's go to the next one. And another fraction. Lovely. What do we need to do here, Audrey?
Multiply by 5 halves.
So multiply by 5 halves? Well, we could do that. All right, we can multiply everything. Instead of by 5, we could multiply by 5 halves. And that actually worked pretty well. If I remember that the 2D class is a 2D over 1, and this is a 4 over... So this is numerator. This is numerator. 2 is denominator, right? Here, of course, we see the 2/5 canceling, just leaving me with the absolute value of 3D negative 4. Audrey, what did you get when you multiplied 5 halves times 2D?
10.
Oh.
5.
5D, because this 2 numerator will cancel with this 2 denominator. Maybe it would be a little easier if we took the time to write it off to the side like this. Now we can see the 2's canceling, and there's the 5D. What about over here? 4 over 1 times 5 over 2.
10.
That is a 10, right? We get a 1 and 2 to get a 10. Again, maybe the better part of wisdom, and this would be my thought, is maybe just multiply everything by the 5 first and get 2. Okay, if I multiply just by the 5, forget the over 2 for now. 2 times the absolute value of 3D minus 4. And then here equals 10D plus 20. Then go through and divide the 2, and that will take you to the same thing. Maybe doing it in 2 steps would be easier. Now, it worked out just fine. We just have to be careful, right? There's just places we open ourselves up to mistakes. So maybe 2 steps is better than 1, just depending on how accurate you can be. How many got to this point, though? All right, questions on what we just did. I kind of showed it quickly. Does anyone need to see that re-explained? All right, let's take it from here then, Audrey. And I'm going to go ahead and clear off some extra space here. Walk us through.
You get 3D minus 4 equals 5D plus 10. And then 3D minus 4 equals negative 5D minus 10.
All right, sliding this out of the way. Now what?
We move the 3D over, and 2D plus 10 equals negative 12. And then we bring the 5D over as a positive to get 8D minus 4 equals negative 7. And then you bring the 4 over 8d equals -6. And then you divide -8 to get 3/4, -3/4.
Good, -6/8, which reduces to -3/4. There's one possible root. All right, coming back up here.
And the 10 over is negative. You get 2d equals -16. So it's -8. 14, which is -7.
All right, so there's possible answers. I'm going to circle them for now. I'll cross them out if I need to. There's my two possible answers. How many got this far? Those who had made it here, hands up if you also made it to these two possible roots. All right, questions where we are now. All right, now comes the fun part. Let me give myself some more room. Let's test them out. So going back to the original, we had 2/5, the absolute value of 3d -4 is equal to 2d +4. I'm definitely starting with the -7. 3 times -7, class? -4. Absolute value of -25. What is 2/5 of or times 25? You may use your calculators if you need them. 10. Many of us didn't. Some of us already done it. All right, now let's take 2 times -7. -14 plus 4. Ooh, does it check? No. I will say this. I am super confident that one's going to check then. Because both of them being extraneous, I hesitate to say never, but I can't think of an example in my time where both have been extraneous. Is that a fair way to put it? I'm not going to say it can't happen, but I don't remember ever seeing one that both of them were extraneous. That said, what if we screwed up on this one, right? If this one comes out extraneous also, then maybe we messed something up in our math. So it's still worth it to check both unless you're running out of time on a quiz or test. In which case, if the first one's extraneous, just assume the other one's not and move on with life and get the rest of the quiz done. But we've got time, so let's check the -3/4. Calculators at the ready. 3 times the -3/4. -9/4 or -2 1/4 minus 4.
-6 1/4.
Absolute value, of course, would just be 6 1/4. So we have 2/5 times 6 1/4. -2 1/2. Someone corroborate there. Yes, that is what I'm getting as well. Well, except not negative. Remember, we took the absolute value, so this is positive. So 2 1/2. All right. Then on the other side, 2 times -3/4
-1 1/2.
plus 4.
2
2 1/2.
All right, there we go. We were pretty sure it was going to check. It does. There's our only solution. -7 is extraneous. All right, questions on this? Questions on this? All right, well, that wraps up the material before we get to our exam. So we are ready to start reviewing for the exam. Of course, the entire next lesson will be exam review. But I want to kind of use this time to give you a rundown on the different topics to be prepared for. You have the weekend. Now, if you're watching on YouTube, you may or may not have the weekend. But you students have the weekend to start looking over these topics before the review lesson on Monday, which of course will be before the exam on Tuesday in lesson 44. Here's the topics to jot these down. Order of operations is where we'll start. Order of operations. Of course, you remember parentheses and grouping symbols, then your exponents, then your multiplication, division, addition, subtraction. Okay, so order of operations would be the first thing. All different things with involving exponents, whether it be multiplying like bases in which you would, thank you, Abby, add the exponents. Divide like bases, we would subtract the exponents, raise the power to a power, multiply the exponents, take the root of a power, divide the exponent by the index, right? So for instance, if we had the cube root of m to the 12th class, we would get m to the 4th, right? Because we're dividing the 12 by the 3, right? To get the m to the 4th. What does a negative exponent mean?
It's a denominator.
Reciprocal. So if it's in the top, move it down. If it's down, move it up, right? Reciprocal, move its location. So for instance, if we had 1 over a to the -3rd, that would just be
A to the 3rd.
a cubed. But if we had an m to the -2nd, that would be
1 over n squared.
1 over n squared, right? We just take the reciprocal of whatever we got. Reciprocal of 1 over a cubed is a cubed. Reciprocal of m squared is 1 over m squared. Anything to the 0 power?
1.
Equals 1. Anything to the 0 power equals 1. So lots of exponent-y stuff that we talked about in this first quarter. Removing parentheses. Parentheses are preceded by a positive. Take them off. Parentheses are preceded by a negative. Change all the signs, right? The first one included. Sometimes we forget about that first one. If parentheses are preceded by a monomial, distribute. If you have a couple of binomials being multiplied, FOIL, right? Stuff like that there. We talked about combining terms. And we said you can only combine terms that are like to each other. Now, if we had a couple of like terms, like a negative 3xy and a negative 5xy, these are like because the xy's are the same. We would say the letters, the literal coefficient, the variables are perfect matches. Well, here, because we have a negative 3 and a negative 5, we would end up with a negative 8xy. Remember, you'd add and keep the sign. But if we had a positive 3 and a negative 5, we'd get a negative 2xy. Signs are different. Remember, you'll subtract the numbers, but keep the greater sign. Or if this were the negative 3 and this were the positive, then it would be positive. Because the signs are still different. We still subtract, but now this is the greater sign, so we keep the positive. Algebraic representation. If you get something like increased by, that means you should add. Or if you get something like diminished by, subtract. If you see the term product, multiply. If you see the word sum, add. If you see is not greater than, less than or equal to. If it's not greater than, that means it could be less than or equal to, right? If you had just less than, subtract. Is less than, use a less than symbol, right? So for instance, 8 less than 5. 5 minus 8, right? Or also remember that than means you flip the order, right? But if it said 8 is less than 15, I won't say 5 because that would be a lie. Now I would say 8 is less than 15. So the is gives you, normally is means what? Equals. But when we have is and then some comparative, that means we have to use an inequality, right? Stuff like that. Okay, that's all goes back to that first section. To multiply terms together, what are my 3 steps? Sign, number, letter. If we want to divide, we again would have sign, number, letter. We already said this, but a monomial times some polynomial, we would use distribution. A polynomial times some other polynomial, we would use double distribution. You said it already. 2 similar binomials class, we would multiply using FOIL. If we had a pair of conjugates, sum and difference, we would do what 3 things?
Square the first, square the last, put a minus.
Square the first, square the last, put a minus sign. If we had a binomial that we needed to square, what would be my 3 steps to squaring it?
Square the first, square the last, multiply and double.
Square the first, square the last, multiply and double. To divide polynomials, or divide monomials, we said sign, number, letter. If we had a polynomial, something like, I don't know, 8x cubed plus 12xy minus 4xyz, I don't know. And we divided it all by saying negative 4x.
Reduce.
Well, in this case, we would divide sign, number, letter once, twice, thrice. Right? We divide sign, number, letter a few different times. It's kind of like distribution, but you're dividing out the negative 4x instead of multiplying the 4x. However, if you try to divide by a polynomial, you can't do it that way. How do we divide a polynomial by another polynomial?
Synthetic division.
Sometimes we're lucky.
Division problem.
That long division, right, where you divide the first by the first, then you multiply by the whole divisor, and then you subtract or add the inverse, then you bring down the next term, and you go through the whole process again, right? You want that descending order. All that sound familiar? Like there used to be a poster over there, but it's not there anymore. If you want to point to it, it's not there. But if the divisor's special, we could use synthetic division. What would the divisor have to be, Michael?
Positive number. Letter and a number.
Letter plus or minus number. So not like a W squared, just a plain old W, for instance, and then plus or minus just a plain old number like a 2 or a 17,000, as long as it's a plain old number, okay? And you could use the synthetic division. It'd be nice to me we won't have divisors like that, right, Kendall? Mm-hmm. Anyway, factoring, that's a big one. That's in all caps in my review notes. I would put that in all caps in your notes. Factoring is going to be a big deal. There's a reason this poster has stayed up all this time. Not that people on YouTube could see it, but this poster stayed up even after we finished the section on factoring. It stayed up while we talked about fractions. We're not even using factoring right now, and yet it stays up because we will come back to it. We always come back to it. So factoring, big deal, right? First thing we should always check for when we factor, class. Common factor. If we happen to have a perfect square, positive, even in a trinomial, then that might be a perfect square trinomial, which would factor into a binomial squared. If we have a trinomial, but it's not a PST, but at least got descending order, then maybe we would backwards FOIL the quadratic trinomial. If we had a 4-term polynomial, or maybe even a 6-term polynomial, we could use grouping to factor it. If we have a perfect square minus some other perfect square, it's a difference of squares, so we factor it into a sum and difference, or a set of conjugates. If we had an odd power plus or minus the same odd power, then we could factor it into a
binomial times a polynomial.
Binomial times a polynomial. If they're cubes, odd powers that match, it'd be binomial
Times a
trinomial, right? But as long as they're odd powers and they match, binomial polynomial. We looked at that. So factoring. Factoring kind of leads into what we had even on our last test, which involved fractions, right? We said in order to add fractions, you have to have a
similar term.
Common denominator.
To add fractions, got to have a common denominator. We said that if you have any fraction, the goal is always to try to make it smaller or reduce it, right? But we said we can reduce by canceling stuff, but we only cancel factors. We never cancel terms. And so, of course, if you wanted to reduce a fraction, you better do what first? Factor, right? You can't cancel factors if they're not there, so factor it up. However, if you cancel a factor out of the denominator, said you have to set it unequal to 0. We said when you multiply fractions, it's kind of like a big reduction problem, except you multiply everything that's left over at the end. So again, factor and cancel. Dividing fractions, well, we don't really do that here, right? We multiply by the reciprocal, right? We don't also, by the way, ever subtract anything, much less fractions. We would add the inverse. We said a complex fraction would be like a fraction in the numerator over something else, or even a fraction over another fraction, for instance. But we said a complex fraction really is just a division problem, right? And of course, we'd multiply by the reciprocal. We talked about values that if you tried to work them out on the calculator, for instance, they'd give you this weird decimal that never ended and never repeated. We would call those values irrational. Okay, irrational values, values that never terminate nor repeat. And usually irrational values come about because you try to take a root. What's that symbol called that we would use to take a root? Radical sign, right? The radical sign kind of looks like a funny division sign, but it's a radical sign. By the way, that might help you remember. Take the root of the power, divide exponent by index. Kind of looks like a division sign. But the radical sign, right? And what that indicates that we're having a root. What do we call the thing inside the radical? Radicand. And this number here is our index. It tells us which root we're taking. We have a lot of memorized rational roots, but most roots are not rational. Most of them are irrational. We said we always want to reduce radicals as well. Normally, that means, for instance, if we had like the cube root of 250 r to the 8th or something, what would I want to do with my number? Factor. When in doubt, guess factor. We would want to factor it, right, into something that is a rational radicand with the irrational part to make it smaller. We said, though, if we have a big index, for instance, we've got, like an 8th root of something like, I don't know, a 36 m to the 6th or something. If we have a big index, we normally want to make it smaller, but the key would be to rewrite as something to a power squared or cubed, right? In this case, 6 squared. And once we have that, we can try to make things smaller. We also said if we ever have the root of a fraction, we have to take the root of the denominator. We said in order to add radicals, they have to be like or similar, meaning they have the same and the same radicand. But to multiply or divide radicals, they just have to be the same order, have the same index, right? We just divide them, though we said you can't always divide, right? So sometimes if you can't really divide, treat it like a fraction and reduce, okay? For instance, you can't divide the square root of 6 by the square root of 10, but you can reduce that down to the square root of 3/5, and then you do what you would have done a minute ago here, right? We said when you square a square root, you get the radicand. For that matter, when you cube a cube root, you get the radicand as well. I saw you mouthing it over there, Maddie. By the way, a square root of 6, for instance. There's a way I could write that with an exponent. What exponent means square root? The 1/2 power. What exponent means cube root? 1/3 power, and so forth. Of course, then we talked about equations. Those are algebraic expressions with equal signs. And of course, inequalities as well. The big difference is with the inequality, if you divide by a negative, you have to flip that sign around the other way. And we've spent a lot of time working on that. Of course, we talked about different kinds of equations, identities, conditional equations. We talked about different kinds of intervals, right? Unbounded and bounded, closed, open and mixed, all kinds of stuff like that. So a lot of terminology to be ready for. We're going to practice these concepts. I ran through them in about, 15, 20 minutes. Ran through a whole litany of things we've talked about. It's been a busy quarter, hasn't it? And pretty much this is what we were supposed to cover in the first 3 weeks of the year. Aren't you glad I didn't follow Rebecca's plan? Yeah, you wouldn't have remembered any of it. So I figure it's worth it to slow it down, make sure you actually have it mastered as opposed to just rushing through and hoping for the best. So do slow it down a little bit. All right, we'll have a wonderful weekend. There's no written homework, but you just wrote down a whole bunch of stuff that you may need to study over in preparation for Lesson 44's exam. When the bell rings here in just a few minutes, you'll be dismissed. Have a wonderful rest of your day and a wonderful weekend.